Good morning, friends. In the last lecture, we talked about the different method in order to calculate the order of reaction. Last, we have seen this particularly the equifraction method. That formula n is equal to log to the base 10 t half first minus log to the base 10 t half second minus log to the base 10 a2 minus log to the base 10 a1 plus 1. This formula can be used to calculate the order of the reaction. Here are the numerical solved on these methods. And last we have seen the Ostwald isolation method. Here we can calculate the order of reaction having the reaction consists of the N1 molecules of the A into molecules of the B and 3 molecules C. The total order of the reaction will be N is equal to N1 plus N2 plus N3 likewise. Okay. Then we have to see the numericals that particularly MCQs based on this particular topic. Which of the following includes all the aims of the kinetics? You can go through this particular thing. Reaction, all the MCQs, whatever the probable MCQs we have discussed already during the topic. Here you please go through this thing. These are the MCQs. You can see these MCQs and try to remember. These are the match the column is there, true or false is there. Please go through all this part because the question will be based on the any part of this. Any MCQs will be there. That's why I'm only showing you that part. Okay, so many MCQs are here. You can go through this. Answers are again given over here. Okay. Please go through this thing. If you are not getting it, then you can ask. Now today we are going to discuss the new topic, new lesson of the unit 1 of the paper 2, that is the liquid stat. While doing the important physical measurements like the surface tension, viscosity, refractivity of liquids, which has considerably increased because of their usefulness in the elucidating composition and the structure of the molecules. Now, of course, we have far more suitable methods like the spectroscopic methods available for this purpose. The various physical properties based upon this measurement can be broadly classified into additive and constitutive property. What are the additive and the constitutive property? It may come for the MCQ. An additive property of a molecule is defined as the one which is the sum of the corresponding properties of the constituent atom. Additive itself indicates that addition. Okay. Thus, the mass or weight of an atom does not alter the molecular weight of the substance. Can be found out by adding of atomic weights of the various atoms present in the molecule. Similarly, the molecular heat of the compound is the sum of the atomic heats of the atom present in it. A constituent property of the molecule may be defined as a property which depends upon the constitution of the molecule, that is, upon the arrangement of the atoms within the molecule. Optical activity is the property which is due to the presence of asymmetric carbon atoms in the molecule. This property is purely constitutive property. Example, you have to remember additive property. Here you have given the molecular heat, then you can see okay. Then there are some properties like the viscosity, reflectivity, etc. are partly additive and partly constitutive. Surface tension. A molecule in the interior of a liquid is completely surrounded by the other molecules and hence on an average it is attracted equally in all directions. However, a molecule on the surface of liquid is subjected to resultant inward pull because there is a greater number of molecules per unit volume in the liquid than in the vapor. Because of this inward pull, the surface of a liquid tends to contract to the smallest possible area and as behaves behaves as if it were in state of tension. It does explain why a small amount of liquid ego, mercury, a raindrop, etc., always take a spherical shape because the sphere has the least surface area. The tension produced on the surface, which is pulled to side of the liquid, is called as the surface tension. Or it may be defined as the force in Newton acting along the surface of the liquid at right angles to any line of 1 meter in length. It is expressed in Newton per meter. It may come for the MCQ surface tension definition of the surface tension. Please see this. What is the surface tension? That is tension produced on the surface which is pulled to the side of the liquid is called as the surface tension. Okay. Then determination of the surface tension by the drop number method. Surface tension of a liquid can be determined using an instrument called as a Trobbe's stalagnometer. It may come for the MCQs. Which instrument is used to determine the surface tension? That is a stalagnometer. In this method, the number of drops formed from fixed volume of a liquid between marks A and B in the figure is determined. The method is called the drop number method. Again, it is called the drop number method. The lower portion of the stalagnometer consists of the fine capillary tube through which the liquid can flow. Here you can see the capillary is there. Then the upper portion is connected by the rubber tubing to a gamma shaped glass tube, Y shaped glass tube. At the start, the screw clamp is closed and the given liquid is sucked into the stalagnometer to a level above mark A. By opening the pinch cock is then closed and the screw clamp gradually opens so that the number of drops flowing out is between the 15 to 20, 15 and 20 per minute. Once this drop rate is achieved, the screw clamp is left undisturbed. The liquid is then again sucked in by opening the pinch cock without allowing any air bubble to remain in the capillary. The number of drops form while the liquid flows from the mark A to B is then determined. Let this number be noted by the N1. If 2 pi or gamma 1 cos theta is the force due to the surface tension on a simple drop, then the force for the N1 drops will be the 2 pi or gamma 1 N1. Cos theta. This latter force will have to balance by the weight of N1 drops, which is m1g, where m1 is the mass of the N1 drops. 2 pi n1 gamma 1 cos theta is equal to m1g. 2 pi n gamma 1 cos theta is equal to v d1g. Mass is nothing but the volume into density that is taken. The stalagnometer is then that is what we can say is clean and dried, and the same procedure repeated with another liquid of the surface tension gamma 2. Let the number of drops obtained in this method for this another liquid is n2. Then when you compare, hence you can determine n1 n2 gamma 2 is equal to, or the n1 by n2 is equal to d1 by d2 into gamma 1 by gamma 2, or say gamma 2 is equal to n1 by n2 into d2 by d1 into gamma 1. Hence, if the n1 n2 are determined and so also the densities of the two liquids, then the separation of any liquid can be calculated if the other liquid is known. Here the surface tension for the few example is given: water 72.75, Newton per meter is there. Okay, these are the examples, various examples are there. Here the numerical is solved on based on this particular part. Okay, remaining part we will see in the next lecture. Here we will stop. Thank you.